Hey guys, Mr. Burns here with your video for lesson 1.4T, scale drawings. One place that you'll see scale drawings, a familiar place, is in social studies class when you guys are using your atlases and, looking up various things and various information about countries. But yeah, if you guys look at your maps, usually there's going to be some sort of a scale to that map. All right, let's dive right into it. This is just kind of like the introductory page, but let's go ahead and jump right into numbers 1 through 4 on the first page of your guys' packet. So here we go on the first page of our packet for this video. So it says a map has a scale of 1 inches to 2 inches, to 2 miles. It says use the given map distance to find the actual distance. So for number 1, we've got 3 inches. And then off there to the right, it says use the ratio table to show the ratio of inches to miles. So the first thing it starts off with is its base scale, which is 1 inch is 2 miles. I call it a base scale because that's the scale that you start off with, right? So 1 inch is 2 miles. Well, if you want to know how many miles are in 2 inches, what are you going up by a factor of? In other words, what are you multiplying 1 by to get 2? That's 2. So whatever you do to the bottom, okay, whatever you do to the inches, you also have to do to the miles. So if 1 times 2 is 2, then you also have to consider what's 2 times 2? That's 4. So 2 inches on the map is the same as 4 miles in real life. Okay, so if it's 3 inches on the map, so we're going up by a factor of 3, what's it going to be in real life? In other words, how many miles is it going to be? So 1 times what is 3? That's 3. And then whatever you do to the top part of this ratio table, you do to the bottom part of the ratio table. So 2 times 3 is what? That's 6. All right. So 3 inches on the map is equal to 6 miles. And that's 6 miles in real life. So knowing what we know now and having our ratio table set up, let's go ahead and figure out numbers 2 through 4. So numbers 2 through 4, they give you the distance in inches, so that's your map distance. And what they want us to do, they want us to convert those map distances to actual distances. So let's go ahead and figure this out for number 2. So number 2, they give us 10 inches. Okay, and again, what they want us to do is they want us to take the 10 inches and convert it to miles. So let's start off with our scale on the map. So the map scale, okay, in this case, is 1 inch to 2 miles. Okay, so what are we going up by a factor of? So they want us to convert that to 10 inches. So what do we multiply 1 by to get 10? We multiply it by 10. And whatever we do to the bottom or top, we also have to do to the bottom. So we're going to multiply the denominator by 10. And then 2 miles times 10 is 20 miles. Okay, and that's how you convert from the map distance to the actual distance. Okay, on number 3, we've got 12 inches, and they want us to take 12 inches and convert that to an actual distance. So here we go. Start off with your map scale, which is 1 inch, which is, put that back up there, 1 inch to 2 miles. That's your map scale. And they want us to convert that to 12 inches over how many miles? So what do we go by a factor of? In other words, what do we multiply 1 by to get 12? That's 12, so 1 times 12 is 12. And then whatever we do to the top, we also have to do to the bottom. So 2 times 12, and what's 2 times 12? That's 24. And it's 24 what? Miles. So on the map, it's 12 inches, but in real life, it is 24 miles. Okay, moving on to number 4. On number 4, we've got 2.5 inches, okay, on the map, and they want us to figure it out what it is in real life. So start off with your map scale. So 1 inch over 2 miles. They want us to convert that to 2.5 inches on the map. And how many miles is that in real life? So what are we going up by a factor of? We are, in fact, going up by a factor of 2.5. And whatever I do to the top, I do to the bottom. So 2 times 2.5. Okay, 2 times 2.5 is 5. Trust but verify. Okay, that is in fact the case, but yes, 2.5 inches on the map is 5 miles in real life. Check it. Okay, check it, check it, check it. All right, numbers 5 through 8. Here we go. On numbers 5 through 8, it says a map scale has, a map scale has a scale 1 centimeter to 10 kilometers. Use the actual distance and the ratio table to find the map distances. So here we go. So on this one, they give us they don't give us the centimeter aside from 1 centimeter, but they do give us the kilometer, which goes 10, 20, 30, 40, 50, 60 kilometers. In order to figure out, the centimeters and kilometers, you can do the same thing. Think of factors. So what are we multiplying 10 by to get 20? You're multiplying it by 2. So 10 times 2 is 20, and whatever you do to the bottom, you also have to do to the top. So to find out how many centimeters there are, you go 1 times 2, and 1 times 2 is 2. Oops, not squiggly, it's 2. So again, 10 times what is 30? That's 3. So then 1 times 3 is 3. Okay, so 3 centimeters is the same as 30 kilometers. And then, let me back up. 30 kilometers in real life is the same as 3 centimeters on the map. So here we go, moving on. So 10 times what is 40? That's 4. So then 1 times 4 is 4. 10 times what is 5? 50, that's 5. And then 1 times 5 is 5. And then 10 times what is 60? That is 6. And then 1 times 6 is 6. So now that we have a completed table, we can go ahead and answer numbers 5 through 8. So on number 5, 30 kilometers in real life is how many centimeters on the map? If we look at it, so we go over 30 kilometers is the same as 3 centimeters on the map. Number 6, we've got 40 kilometers. 40 kilometers in real life is how many centimeters on the map? That's 4, according to our table. Number 7, we've got 100 kilometers is how many centimeters on the map? But according to the the table here, our little map table, it doesn't extend out to 100 kilometers, but we can figure it out knowing what we know now. So let's go ahead and set it up. So our map scale, our original map scale is 1 centimeter. So 1 centimeter over 10 kilometers. And if we want to change that or convert that, the kilometers to 100, we got to ask ourselves, what do we multiply 10 by to get 100? And that's 10. And whatever we do to the bottom, we also have to do to the top. So 1 times 10 is 10. So in this case, 10 centimeters on the map is the same as 100 kilometers in real life. Okay, here we go with number 8. On number 8, you've got 55 kilometers, and we have to convert that to centimeters to find out what the distance is on the map. So let's go ahead and fill out our chart. And 5 and 6, because we know that. So 5 centimeters on the map is 50 kilometers in real life, and 6 centimeters on the map is 60 kilometers in real life. Well, 55 kilometers, this one, you don't have to use a whole lot of fancy math. I mean, you can, but you can also use some common sense, right? So 55 kilometers is right in between 50 and 60. Okay. And if we remember our conversion rate, which is 1 to 10, if I go 1 times 5, that gives me 5. And if I go 1 times 6, that gives me 6. So if I go 1 times what's right in between 5 and 6, 5.5, I get 5.5 centimeters on my map. Just for the heck of it, if we were to do the same thing, if I go 10, just to check it, 10 times 10 point, nope, Mr. Burns make mistake. So if I go 5 times 5.5, so whatever I do to the top, I do to the bottom, right? What do I get? I get 55 kilometers. So for the answer for this one is 5.5 centimeters. All right, pretty cool. All right, Moving on to number 9. Okay, so here we are on number 9. And on number 9 it says a wall is 2 inches long in the scale drawing. So I'm going to go ahead and write that down. So 2 inches. The actual wall is 10 feet long. Okay, set it up as a ratio. It says, what is the scale for the drawing? So all you have to do in this case is just simplify. So what's the greatest common factor of 2 and 10? In other words, what number will go into both 2 and 10 evenly? What's the biggest number you can think of? 2. So I'm going to divide both the numerator and the denominator by 2. And then 2 divided by 2 is 1. And then 10 divided by 2 is 5. So the scale for this drawing is 1 inch to 5 feet. And that is your final answer. Okay, moving on to the next page. Okay, here we are on the second page. So the instructions for numbers 10 and 11 say, find the scale factor that was applied to each figure on the left to create the figure on the right. So on number 10, you've got this quadrilateral, and let's talk about the corresponding sides first. So it says, write the ratio of the two corresponding side lengths and simplify. So the corresponding sides, so both of these quadrilaterals are oriented correctly. In other words, they match each other, right? So side length 5 corresponds with side length 20, and side length 4 corresponds with side length 16. So the figure on the right, so that's the larger figure, so pick a side, right? So let's say 20. And what is its matching side on the figure on the left? That would be 5. And then at this point, all you have to do is simplify. So what's the greatest common factor of 20 and 5? That would be 5. And again, trust but verify. So 20 divided by 5 is 4. And then 5 divided by 5 is 1. Now, since we're talking scale factors, I like to leave my scale factors written like that as an improper fraction. If you wanted to simplify that all the way, you can. So how many times will 1 go into 4? It'll go in there 4 times. So that's another way to rewrite the scale factor. Me personally, being who I am and how I am, I like to leave it as the fraction on the top as an improper fraction. So either way is right. Depends on you. We're all individuals here, right? Okay, here we go. Moving on. Number 11. So in number 11, we've got two triangles. And it says, write the ratio of two corresponding side lengths and simplify. So now you get to choose. Well, sort of, kind of. So it says the figure on the right. So choose one of those sides. Let's say 12. And what is the corresponding side on the left? Figure on the left, that would be 36. And then in this case, it asks us to simplify. So what's the greatest common factor of 12 and 36? The greatest common factor of 12 and 36 is, let's say it's 4. So if I go 12 divided by 4, that gives me 3. And I go 36 divided by 4, that's 9. So is that simplified? No, Mr. Burns, you didn't get it right. You didn't get it right. So again, what's the greatest common factor of 3 and 9? 3. So if I go 3 divided by 3, I get 1. And if I go 9 divided by 3, I get 3. And when the numerator is 1, you're done reducing. So 1/3. Okay, you guys got that? All right, let's move on to number 12. On number 12, it says, a blueprint of a house has a scale of 1 inch to 2 feet. So if you guys take an architecture class or work with a CAD program, a computer-aided drafting program, you'll be able to create and design like your own houses and things like that. So learning to use a CAD program and learning to, some basic architecture skills like how to design a house is really, really fun. In high school, I had a chance to take an architecture class and we designed our own home and it was fun. So anyways, moving on. So for part A, it says, find the actual length of a wall that is 8 inches on the blueprint. So here we go. I'm going to expand this a little bit, and so it makes it a little bit easier for me to write. Hold on. Okay, so for part A, the first thing I'm going to do is I'm going to write down what the scale factor is. So the scale factor is 1 to 2. So 1 inch to 2 feet. And on the drawing is 8 inches long. Okay, we want to find out how much it is in real life. So we got to ask ourselves, what's the factor I multiplied 1 by? That's 8. And whatever I do to the top, I do to the bottom. So 2 times 8 is 16. So in real life, okay, the wall is going to be 16 feet long. Okay, so that's my final answer. On to part B. Part B says, find the length. Okay, so find the actual length, the actual height of a wall that is 4 inches on the blueprint. So same thing, I'm going to start off with what I know. I know what my scale factor is, 1 inch to 2 feet. I know on my blueprint, it's 4 inches. I got to find out what the actual is. So 1 times what is 4? That's 4. And then 2 times 4 is what? 8. And 8 what? Inches or feet? Since this is a story problem, we have to remember our labels. That's important. So it's 8 feet. All right. Part C says, what is the area of the actual wall in square feet? So to find the area, okay, of this room, so we're going to assume it's a rectangle. Okay, so what is the area? Remember what the formula for the area is? You've got length, and you've got width. And to find the area, okay, of a square or rectangle, it's length times width. So what's the length? 16. What's the width? 8. Okay, and then what's 16 times 8? 16 times 8 is 128 feet squared. All right. Again, trust but verify. Use your calculators. Make sure that's right. Okay, let's move on to part D. On part D, it says, if another wall is 20 feet long in the house, how long is the drawing of the wall on the blueprint? Same thing. Start with what we know. We know what the scale factor is. It's 1 to 2. And that's equal to, what do they give us in this problem? They give us the feet, so that's in the denominator. So 20. So what is it going up by a factor of? In other words, what are we going to multiply 2 by to get 20? That's 10. And whatever we do to the bottom, we do to the top. And 1 times 10 is 10. And it's 10 what on the drawing? It's 10 inches. That is my final answer. All right, you guys, I hope these videos are helpful. I do know sometimes I mumble and I bumble, but I appreciate you guys and your patience with me. That's all I got. Have a good day. Mr. Burns, out.